Hello everyone, my name is Chinmay Shukla and my ID is 24CE118 and my topic is nanotechnology in electronics. Nanotechnology refers to the technology in electronic compound that this term covers basically those components which are very small, which are in the range of we can say 1 nanometer to 100 nanometers. We can say about the history of nanotechnology that first there was a lot of issues among the chip manufacturers that how to store a lot of data on a single chip. So for decades, computer chip designers have been desperately trying to do so. So in 1965, Gordon Moore predicted his famous Moore's law that for each new generation, the number of components in chip would quadruple every 3 years. Then there is a series of history where we can see that in 1960, two scientists have developed the first MOSFET. Then the same scientists in 1962 fabricated a nano layer based semiconductor junction transistor. In 1996, we see that professor of North Carolina have demonstrated that his new nanowire made from the chain of compound from phenylene. In 1997, DARPA awarded a contract to a research group UC Berkeley to develop a deep submicron delta transistor. In 1997, Arizona University, a three-molecule photovoltaic device used was made to convert light into electricity. At Stanford University, there was a demonstration use of carbon nanotubes. They successfully then fabricated FinFET device down to 17 mm in 1998, then 15 mm in 2001, and 10 mm in 2002. In 2006, a team of Korean scientists developed a 3 mm MOSFET, the world's smallest nanoelectronic device at that time. Then we find that the commercial production and sales started by 2010s. The nanoscale components used in nanoelectronics are majorly, bifurcated in two ways. First is the inorganic nanocrystals, and second is the organic molecular components. In the inorganic nanocrystals, such as nanotubes and nanowires, named after their physical shape determined through the use of growth kinetics. They are typically low dimensional up to nanoscale structures. Semiconductor nanowires may find a number of use in chip technology due to their they are very compatible and of the process of silicon fabrication, deterministic electrical properties, and variability of material sections. We find that they are very small and can be easily fabricated on the semiconductors. So it's very useful in chip manufacturing. The molecular components are like single molecular or molecular monolayers and supramoleculars with different schemes are prepared by amalgamation, and therefore less variation is probable in its chemical composition or structural parameters. Molecular nanocomponents have amazing future in manufacturing of low power, ultra dense, and low cost computing chips. There are many approaches in this nanoelectronics. First is nanofabrication. The main articles are nanocircuitry and nanolithography. Electron transistors, which involve transistor operation based on a single electron. Especially for those transistors where we can find that only one electron is required, we make it by the approach of nanofabrication. It can construct ultra-dense parallel array of nanowires as an alternate to synthesize nanowires individually. Second is nanomaterial electronics. Besides they are being very small and allowing more transistors to be packed into a single chip. The uniform and symmetrical structure of nanowires and nanotubes allow a higher electron mobility and a symmetrical electron hole characteristic they show. That's why nanomaterial electronics and is an approach that is used in nanotechnology in electronics. Nanomaterial electronics, besides being they are being very small and allowing more and more transistors to be packed on the single chip due to its uniform and symmetrical structure of nanowires, or basically the nanotubes allow a higher electron mobility. And that's why they are very useful for this purpose. By we can say in molecular electronics, a single molecular electronic device are very great extensively researched nowadays, as we discussed in a previous slide that it has a very bright future ahead. These schemes would make a heavy use of molecular self-assembly. We know that it can be used to make a very dense and a low power, we can say the low power chips we can construct through this. Now we are going to discuss about the nanoelectronic devices. Those devices which basically use the this technology in them. High technology production processes are based on traditional top to down strategies, where nanotechnology, it has already been introduced very quite beginning, we can say, due to the critical length scale of IC circuits is already at nanoscale, 50 nanometer and below, regarding the gate length of transistors in CPUs or DRAM devices. So in computers, nanoelectronics hold the promise of making computer processors more powerful are possible with conventional semiconductor fabrication techniques. As we know that as the number of as this, we can pack more and more transistors on small chips. We are we are actually allowing the computer to store more and more data, and it helps in basically in the CMOS components, which both use the semiconducting carbon nanotubes. In memory storage, we can say that many devices like the magnetic RAM use this technology to store the memory. They largely actually rely on transistors. That's why, as due to the introduction of this technology, it is very useful in memory storage actually. As on a very small chip, we can store a lot of transistors, and since due to that reason, we are able to store a lot of data on a very small scale chips. As we know that there are new displays like OLED or QLED. These are all due to we can say the due to the introduction of nanotechnology in electronics. In future we know that quantum computers, and even now as well as now they are being utilized. So the major components, or we can say one of the most important technology or a principle on which these computers are being worked are nanoelectronics. So the use of qubit, basically a quantum bit memory space, has been termed qubit for the for several computations at the same time. In nanoelectronic devices, the qubit is encoded by the quantum state of one or more electron spin. The spin are confined by either a semiconductor quantum dot or a dopant. Medical diagnostic. There is a in future there is a lot of possibilities that due to with the help of nanotechnology or nanoelectronics, we are going to able to develop artificial skins which can be used in if anyone has damaged or burned his skin, so we can replace that damaged part with this new technology. So the conclusion, in conclusion, we can say that the future is especially circling around the nanotechnology. The innovation leads nanotechnology drives smaller, faster, and more efficient devices. Scalability, cost, and safety issues need solution. This is the only, we can say, the challenge that is faced, as it is very small, so we can and it require, and currently we are not having any that type of technology which is affordable to us. So we are hoping that we get such a technology that by the end we can easily manufacture it very at a very cheap rate. We should also get a scalable one, and also the safety issues get resolved. And this will definitely happen as continuous research and development is happening on this topic. Thank you.